These are the frequently asked questions for the book assignment for section 4.1. So basically 4.1 day 2 in pre-calculus. And in exercises 9 through 16 it says we're going to convert this from BMS, degrees, minutes, and seconds, into radians. So with number 15 we have 61 degrees and 24 seconds. And we have to figure out what we have in degrees here before we can work forward. So to do that, we remember this is 61 and 24 sixtieths. Well, that's going to reduce the 24 sixtieths to 61, that'll be 2/5. Now if we change that into a mixed number and take 5 times 61 and we add 2, that'll give us 307/5, and this is now in degrees. And they want this in radians, so what we would do is we would make sure that we have something about degrees in the bottom and something about radians in the top. And here the degree labels are going to cancel right out, and you can multiply top times top, bottom times bottom, and this would be an exact answer in radians. But they did go ahead and give us the decimal equivalent here, which would be 1.072 radians as an answer. So if you want to check your answer, you could go that far. 307 pi over 900 does not reduce. So like I said, as a perfect answer, we would leave that. Next one on your list was 33. And 33 is talking about concentric circles. Concentric circles are like a donut. I mean, that's really what it is. And they want us to look at concentric circles that actually are using the same theta, the same angle inside here. In exercises 33 and 34, a central angle theta intercepts arcs S1 and S2 on two concentric circles that have radii of R1 and R2, respectively. Find the missing information. So right away I'm thinking about a little arc length formula. And I notice in number 33 that they've given us R1 and S1, and that will help us figure out what theta is. So I'm going to go ahead and put a 9 in here and an 11 in here, and I realize if I divide this through I get 9/11ths for theta, which is kind of weird because we would expect that to come out in radians. It is, but there's just no pi value that we see there. So now that I know that that is theta, now I can go ahead and figure out what's going on with the arc length for S2, because this was all in the first circle, the little circle. Now everything in the second circle is what I need to find. So for the second circle, they have the radius at 44, and I know theta from the calculations that I just did is 9/11ths. And so we would just multiply that out. 45 times 9 divided by 11, 36 centimeters. So working backwards to find theta in the small circle, and then forwards to figure out our arc length for the larger circle. Next up was 36, and 36 says we have a 100-degree arc of a circle with a length of 7 centimeters. To the nearest centimeter, what is the radius of the circle? So right away, I'm looking at this 100 degrees and thinking this is not useful in our arc length formula because it's in degrees. So I have to change this by multiplying it by pi radians over 180. And I just slap a 1 underneath there so I can go ahead and do the math and do a little reducing and get 5 pi over 9 in radians. And arc length, radius times theta. And they told us here that it has an arc length of 7. So we're going to have 7 equals the radius times 5 pi over 9. Multiply both sides by the reciprocal. And that would give us 63 over 5 pi equals the radius. But it said to the nearest centimeter, so we'd want to go ahead and pop that into a calculator. And 63 divided by 5 pi is 4.011 centimeters. So we go ahead and say it's about 4, since they said to round it to the nearest centimeter. Next up, number 39, compass reading. The first thing I did with this one was I thought, well, we're talking about degrees, and like it says, north corresponds to 0 degrees, And I noticed in the question they're asking me about these little letters with north, northeast, northeast, east, northeast, all of this good stuff. So I would count up how many there are and just go around and say here's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 of them. So if those are all divided evenly, 360 divided by 16 gives me 22.5 degrees. So for each one of these little arcs here, the central angle would be 22.5 degrees. And that certainly helps us figure out what they want in A, B, and C. Because it says find the angle in degrees that describes the compass bearing. Well, northeast is 2 of these, so that'll be 22.5 times 2, which is 45 degrees. North, northeast, well, that's just one of them, so that's 22.5 degrees. And remember, we're talking about the bearing from due north, so there's that north, northeast piece that we needed there. And then they want to know about west, southwest. Well, west, southwest is all the way over here. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 of those 22.5s. So 22.5 times 11 would give us 247.5 degrees for west, southwest when we find those. Your book might have done this a little bit backwards. They might have asked you which one of these to find for those bearings, but you could certainly work forwards and backwards on this. This might be one of those where I have either a newer text or an older text than you do. The northeast is at 45 degrees, and then the north-northeast is at the 22.5 degree mark. Number 44, this is a whopper of a problem right here. Table 4.1 shows the size specifications for the tires that come as standard equipment on 3 different 2009 American vehicles. And really, this and the names, that's what we care about. Because for A, it says to find the speed of each vehicle in miles per hour when the wheels are turning at 800 revolutions per minute. So the first thing we start off with is just figuring out that arc length for each one of them. All right, so let's go after it. I'll put the Ford in there for S sub 1. So that one's going to be, radius would be half of the 27.2. So 13.6 times 2 pi. And just like the question that we came across in class, you know, we realized we're going to multiply by 2. So we're dividing in half to get the radius, but then we're multiplying by 2 pi in order to get what we need. And that was the Ford. The Charger, 28.6, so that would be 14.3 in our formula, but again, we know we're going to double it anyway, so I would just jump ahead and say that one's going to be 28.6 pi. And the Mercury, 29 pi. Now, that is the inches they travel in 1 revolution. So now, let's actually get to the problem and say, okay, we've got a Ford. The Ford is 27.2 pi inches per 1 revolution. And now what I need to do is figure out how to get that to miles per hour. Well, they told us in part A that these are traveling at 800 revolutions per minute. So times 800 revolutions per 1 minute. And we know that we want miles per hour. So this is where we just get started on our conversions here. And the first one I went after was changing this minutes into hours. So there are 60 minutes in 1 hour. That seemed like a quick and easy thing to do because now the minutes will cancel out. And I'm kind of short on space here, so I'm going to go down to the next line. We have inches up here, and so we need inches on the bottom to get rid of that, and there are 12 inches in 1 foot. And then we need feet to miles, so 1 mile has 5,280 feet in it. So for the Ford, we would multiply. 27.2 pi times 800 times 60 times 1 times 1, numerator, 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 divided by 1 times 1 times 1 times 12 times 5,280, and that is 64.736 miles per hour. Now, the only thing that changes when we do the Dodge and the Mercury is this number right here. So I'm not going to rewrite the whole thing. All you would do for the Dodge is change the 27.2 to 28.6 pi. And you would redo your calculations with that in your numerator. And that would come out to be, for that Dodge Charger, we would have 68.068 miles per hour. For the Mercury Mariner, we would go through the same process again. The only thing that would change is right up here we would put in 29 pi instead of 27.2 pi, and that would come to 69.020 miles per hour. So what we really want to pay attention to, because there is another problem later where we're going to use the same stuff, is what's going on with that particular group of our unit analysis, because that takes what we have for our revolutions and does the conversions for us, changes our inches per revolution into miles per hour. So you really could simplify that by just multiplying everything across the top and getting 48,000, too many zeros, 48,000 over 63,360. And just using that every time, no matter what we have there. Now in B, it says, compared to the Mercury Mariner, how many more revolutions must the tire of the Ford Taurus make in order to travel 1 mile? So what we really care about is pi times the diameter gives us 1 revolution. So pi times diameter inches in a revolution is what we're dealing with. And what we find out here, if we go back and use the numbers from the previous problem, is what we really care about is that 63,360. Because that's the number that takes care of the inches piece for us, so that we can talk about miles per revolution. So this will come out to pi times diameter over 63,360 miles per 1 revolution. So we have approximately 20,168 over D revolutions, because it's all about talking about our little 63,360 from the bottom. The 48,000 that was across the top was what changed our information in revolutions and minutes. And this is just asking us about how much more this is going to have to travel. So when we change this for B, all we have to do is put 20,168 over the diameter for the tire. So for the Ford, that's going to be 27.2, and that's approximately 741.47 revolutions for the Ford. And then for the Mariner, write that so it can be read. For the Mariner, we'll have 20,168 over 29.0, which is approximately 695.45 revolutions. And we would subtract those two because they wanted to know the difference. So there's your Mariner. And we have 741.47 minus 695.45, and that equals 46. I decided to come back after 44B a little bit differently, because if you're struggling with that one, I want to show you a different way to figure out what it is that they want. So B says, compared to the Mercury Mariner, how many more revolutions must the tire of the Ford Taurus make in order to travel a mile? So what we're really looking for here is how many revolutions per mile. Now I'm going to go ahead and let the labels here in the unit analysis help me get what I need. And what that means is if my answer is supposed to have revolutions on the top, I have to think of things kind of upside down and think, all right, what do I know? Well, I know in one revolution that for every single one of these, what I did was really pi d inches. And that's what they want me to figure out, is that pi d inches. But since my label needs to be revolutions per mile, I need to get rid of the inches. I need that to be in miles. So I'm going to use that dimensional analysis and make sure that inches are on the top and the bottom so they will cancel out, and get myself to the point where I'm talking about miles here. So as we do this, we're looking for the canceling in the numerator and the denominator of each of the labels. So if we do it this way, inches will cancel out, feet will cancel out, and we will have the revolution per miles that they want. So this really becomes a formula when we go ahead and say, all right, everything over here is leading up to this revolution per miles. Well, on the top, we'd take 1 times 12 times 5,280, and that would give us 63,360. And on the bottom, we'd have pi d, and this is definitely revolutions per mile, as we can see by the labels. And so this formula, using just pi d generically, allows us to compare all three of the types of cars. So we don't need to, we just need to look at the Ford and the Mariner, but this would give us an idea of how to deal with all of them. So for the Ford, we would have 63,360 revolutions divided by, and it would be 27.2 pi, and that gives us 741.475. And then we do the same math, but with a different diameter for the Mariner. So 63,360 revolutions over, that one was 29 pi. And this would give us, since this is all in miles, this is 695.415. And what they wanted us to do was compare. So that means we're going to subtract. So we have the 741.475, and we subtract from that what we had for the Mariner, which is the 695.415. And we'll get the same answer that I had earlier for this one. But I think this is a little bit better explanation of why the units work out the way that they did. So we're talking about just over 46 again. So second explanation, a little bit more detailed about where all of the numbers come from. For part C, we still had more. And what this is really asking is, what's going on when you compare that new diameter to the old diameter if you've changed those tires out? Well, the new one would be 29 pi, and the old one would be 27.2 pi. And we want to know, basically, percentage-wise, what's changing here, because that would give us an idea of why this is illegal, you know? So if we take 29 pi, that is the new one, and divide it by 27.2 pi, we get 1.066 miles for every 1 mile. Because if we divide this out, what we're really doing when we divide it is we're changing this so it's something over 1. So the old one is going to be 1, but the new one was 1.066. And so you're getting more miles out of that tire by the fact that that diameter is larger. And so what that does is that throws off your odometer and your speedometer. Odometer is what keeps track of your miles, you know, how many miles you have on your vehicle. And that's important because when you go to sell your vehicle, that is a big selling point if you have low miles on your car. So the odometer and speedometer readings would be too low. So that's why there are laws about the sizes that you can have on your tires. It's kind of a buyer beware thing. You know, if you see large tires, the the vehicle actually has more miles on it than you can read off of the odometer. Next one up is number 47, and number 47 has a radial arm saw that has a circular cutting blade with a diameter of 10 inches, and it spins around at 2,000 RPMs. If there are 12 cutting teeth per inch on the cutting blade, how many teeth cross the cutting surface each second? There it is. So what are we doing? Well, we're trying to figure out teeth. So let's see what we know. We've got a diameter of 10. That means our radius is going to be 5. And we have that it spins 2,000 revolutions per minute. 12 cutting teeth per inch. All right, now let's start putting this all together here. If we want to figure out how far this goes in one of those revolutions, we of course have to use S equals R theta. So that's going to be 5 times 2 pi, which would give us 10 pi. So 10 pi inches in one revolution. And we have 2,000 revolutions per minute. And what we wanted to know was how many teeth are cutting each second. I keep wanting to say section. 12 teeth in an inch. So let's see what we have for labels here. The inches would cancel out. The revolutions would cancel out. And right now we have teeth per minute. Well, that's not what we wanted. We wanted teeth per second. So we've got to figure out a way to get rid of minutes and get it to be seconds. Well, in 1 minute, there are 60 seconds. And now minutes would cancel. Seconds would be our label for time. Let me change colors here so I can show you what's going on. This label is going to stick right there. Inches gone, revolutions gone, and you can see the only label across the top there is going to be teeth, and the only label we have left on the bottom here is going to be per second. So we would have, if we multiplied all this out, 753,982.2369, all divided by 60. And because we want this in just teeth, we would probably just round this to the nearest one, you know. But they have approximately 12566.371 teeth, which is kind of weird. Again, we really should say it to the nearest tooth, but teeth per second. So there it is. So this one really, again, just starts with figuring out what the arc length is, which, you know, for this one, it's actually the circumference. And then we go from there. Next up was number 61, and number 61, very similar to what we were doing before. We've got a bicycle with 26-inch diameter wheels, so that's a radius of 13, traveling at 10 miles per hour to the nearest whole number. How many revolutions does each wheel make per minute? So what we see here is we're looking for something a little different this time. We have 26-inch diameter, and I'm going to go ahead and erase that because what I want to do is show you how we're using this formula again to figure out how far we're traveling in one revolution. So we have 26 pi.
Matt Freeze to the main office, please. Matt Freeze to the main office.
26 pi inches in one revolution. We want to know, and I'm going to make that X, how many revolutions in 1 minute. And we know that we have 1 foot to give us 12 inches, and 1 mile, 5,280 feet, and 60 minutes in an hour. Boom. Now, what else did we know? This comes out to 10. So if we do all of this math, we're going to get 10 miles per hour. And this is so much math, I kind of ran out of space. 10 miles per 1 hour. equals all of this. So what would we do? Well, we'd simplify, and then we could multiply by the reciprocal. So we've got 10 miles per hour equals, and on the other side, we'd have to take 26 pi times x times 1 times 1 times 60, which is 1560 pi x over 1 times 12 times 5,280 times 1, which is 63,360, and that should definitely look familiar. We used that before. And then we'll multiply by the reciprocal. So we've got 10 miles per 1 hour times 63,360 over 1,560 pi. That would give us x. And we multiply that bugger out and we get 129.283, and this just happened to be multiple choice. And that is answer B. So this one is a little weird, and it's because part of our unit analysis contains how many revolutions we would need per minute. Then, number 63. Table 4.2 shows the latitude and longitude locations of several U.S. cities. Latitude is measured from the equator. Longitude is measured from the Greenwich meridian that passes north-south through London. So 63 wants us to figure out the difference in longitude between Atlanta and San Francisco. And Atlanta, if we're looking at longitude, so ignore the latitude. All right, longitude for Atlanta and San Francisco. There's Atlanta, and here is San Francisco. It doesn't matter which order we do it in. I guess I'd rather not have it negative, so I'll take 122 degrees, 25 minutes, minus 84 degrees, 23 minutes. So this one works out really nice. We just do degrees minus degrees and get 38, and then 25 minutes minus 3 minutes is 2 minutes. So all you're doing is figuring out, degrees compared to degrees, minutes compared to minutes. Then number 67 says assume that the two cities have the same longitude, that is, assume that one is directly north of the other, and find the distance between them in nautical miles. Now here's the key. 1 minute equals 1 nautical mile. They have the same longitude, so with this one what we want to go after is latitude for San Diego and Los Angeles. So if we do that, we're going to need to take 34 degrees and 3 minutes, and we're going to have to subtract 32 degrees and 43 minutes. So normally what we do is just say, okay, 34 minus 32, that's going to give us 2. But look at what we have for minutes here. We need to do a little borrowing in order to make this work. We're going to have to borrow one of these degrees and make it 33 minutes, 33 degrees, 63 minutes in order to actually do the subtraction that we need here. So we'd have 33 minus 32 is 1, and that's 1 degree. And then we have 63 minus 43, which would give us 20 minutes. Now remember, 1 minute equals 1 nautical mile. So if we can just figure out how many minutes we're talking about here, we know how many nautical miles. Well, 1 degree is 60 minutes, and we have 20 extra minutes, so that is 80 nautical miles.